this video. This is going to go a little bit deeper than what I'm taking most of my pre-algebra students. But for those that are wanting to go ahead and be fully ready for algebra, let's go ahead and take a look about how we can take a equation that's in the slope-intercept format, the y equals mx plus b, where the y is all by itself, followed by the x term, and then plus or minus the constant, and putting it into the standard form. And the a, the b, and the c basically stands for an integer, okay, usually. And I taught you how to get almost to that point, but then I kind of let it slide because I thought, well, this will be close enough. But if you're wanting the challenge, here's how we go. Let's take a look at an equation. And as you can see, this is definitely in the slope-intercept format. To make it into a standard form, we just basically subtracted 3x from both sides, right? Sorry, that was a little messy there. This is a positive y, so we'll pull that down. And we have the positive 4 left over here. Now, let's take a look at this. Does this match up to the standard format? Sure does. This is got a coefficient of a 1 there, so yes, this works. It's no problem at all. So we've gone from a slope-intercept form to the standard form. It works sometimes where you don't have to worry about it, but then we run into other scenarios like the following. Y equals 2/7 x minus 4. And I've already taught you how to basically get there. You could just go ahead and subtract 2/7 x and minus 2/7 x, right? And so this canceled out, and we have negative 2/7 x plus y equals negative 4. Well, here's the issue. See this right here? Everything's cool with this part with the c, because that's an integer. The b, this is again a 1, which we can live with that. It could also be any other integer. It doesn't even have to be a plus sign, because if this was a negative integer, we could put like, negative 3y. So that's fine. It's this fraction right here that's technically not allowed. If we're putting it into a standard form, it needs to be simplified, and fractions just are not going to work for an a, b, or c. So what can we do to get rid of this? Well, let's bring it down here and have a little bit more room to work with. There is that rule that what you do to one side of an equation, you have to do to the other side of an equation. But we're also looking at, when you're messing with one term, you better mess with all the terms in a certain way. Do you see this negative 2 is being divided by 7? Well, what if we were to multiply it by 7? We learned earlier that that would knock that out. So if we would just go through and multiply this term by 7, so 1y times 7 would be 7y. And then if we multiplied this by 7, 7 times negative 4 would be negative 28. See where I'm going with this? And then this negative 2 was free to multiply to x. So now you just ask yourself, was this a positive 7y or is it a negative 7y? It's a positive 7y. That gets you an integer for each one. So we probably want to go through and see that again, but let's write our answer up here. Negative 2x plus 7y equals negative 28. I don't know about you, but sometimes I get paranoid when I see something that's just totally different than the other equation. We said we had this slope-intercept form, and this is the standard form, and it just does not look similar. This, you still got pretty much the same numbers sitting with it. Well, you can actually convert the standard back to slope-intercept to see if you got it correct. So let's add 2x to both sides here real quick just to check our work. And so, the 7y is left on the left side. We'll pull down our 2x first. And it's positive, so it's positive here. And then it's minus 28. And then if you recall, we just divide by 7, divide by 7, and divide by 7. And we're left with this, which is exactly what it's supposed to be. So I know that the standard form equation really does represent this. And it's okay that it looks different. We're just trying to make sure that we don't have any fractions in the A, B, C slot. Okay, so let's do one more equation and see if we can get you used to it. And here we go. We have y equals negative 4/8 x minus 3. So let's go ahead and flip it over to standard form, just to show you the problem that you're going to run into. If you add 4/8 x to each side, that's fine, except for the fact that you're going to be dealing with this. And absolutely, you can go ahead and simplify this down to 1/2. You would be expected to. You simplify whenever you can. You probably should do that before you even move it over there. But you still have a fraction, and this is in the a slot, and that's just not acceptable. So what can we do? Basically, just go ahead and multiply it by 2. And then multiply this by 2. And then multiply this by 2. So 2 times 1/2 is 1. So there's my x. 2 times 1y is 2y. Is it positive or negative? It's positive. And then 2 times negative 3 is negative 6. So this becomes my, whoops, this becomes my standard form. Wow, we're having some tough time putting it together there. That becomes my standard form equation. And we can actually go through and check it by getting this 2 all by itself and seeing if we get this. So let's go through. Let's see, minus x, and we're left with 2y equals negative x minus 6. Divide by 2. And hopefully you can see how, because this has a negative 1 there, that's the same as negative 1/2 x, and this is the same as minus 3, because negative 6 divided by 2 is negative 3. Yeah, it's a little bit different right here, but can't we just go ahead and simplify this down to negative 1/2? I mean, honestly, because 4/8 is the same thing as 1/2. So this x plus 2y equals negative 6, it really is the true standard form of this slope-intercept form equation. We just don't like having these fractions in the a, b, or c slots.